Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 9s. Welcome to today's lesson for natural sciences. This is our third lesson for term 4. The knowledge area is still planet Earth and beyond. And this section contributes 80 marks towards your final examination. So please pay attention and take advantage of the marks because they are relatively easy topics, okay? The topic for today's lesson is the atmosphere and the subtopic is the atmosphere. I'm sure by now you know my name is Kwanele Dlamini and this lesson was proudly brought to you by the Gauteng Department of Education. So without any waste of time, let's get right into it. So what's the point of this lesson? What are we trying to achieve? We are trying to ensure that by the end of this lesson, you should be able to recall the layers of the atmosphere, which are the troposphere, the stratosphere, the mesosphere, the thermosphere, and their main characteristics, okay? You should be able to recall the layers of the atmosphere, which are the troposphere, the stratosphere, the mesosphere, and the thermosphere. And you should be able to recall their characteristics, okay? You should be able to explain that the atmosphere is a mixture of gases held around the Earth by gravity. You should also be able to list the types of gases in the troposphere as the mixture of air, which is 78% nitrogen, 21% oxygen, less than 1% carbon dioxide and other gases, which include water vapor. You should lastly be able to explain that the density of air particles decreases further away from the Earth's surface. Now, for more information on this, you can refer to the grade 9 CAPS document on page 80. Let's continue. So now let's take a step back and revisit some of the concepts that we've learned in previous grades because they lay a foundation for today's lesson, shall we? So we are going to look at grade 4. Okay, in grade 4 we learned about planet Earth and what is planet Earth. Planet Earth is this giant planet that we all call a home. And then we looked at features of this planet Earth. What are the common features that you can think of planet Earth? Okay, we have mountains, we have rivers or oceans, we have land, we have plants, and we have animals, and of course us, human beings, okay, humans. Now, there are many more features like rocks, but for the purposes of this lesson, we are just going to highlight those. We also learned about the Earth in space. We know that the Earth is rotating in its own axis, and each rotation takes about 24 hours. And at the same time, the Earth is rotating around the Sun, and each rotation takes about 365 days. And that rotation is called what? A revolution. So it takes 365 days for the Earth to rotate around the Sun, okay? It's no surprise that we have 365 days in a year. That is because it takes that much long for a year to, for the Earth to complete each cycle around the Sun, each revolution, okay? Right. Then we also learned about the Earth and the Sun. We know that the distance between the Earth and the Sun is about 150 million kilometers. That is a very, very long distance. But surprisingly so, it takes about 8 minutes for the Sun's light to strike the surface of the Earth. So the light must be traveling very, very fast. In grade 8, we learned about structure of the Sun. Okay, we know that the Sun has a structure and it looks like this. So the central region of the Sun is called the core. That's the inner layer of the Sun. It is the core and it's the hottest area of the Sun. Why is that the case? That is because that is where nuclear reactions are occurring, and this is where hydrogen is converted to helium and it releases a tremendous amount of energy. And some of that energy shoots out of the surface of the Sun in the form of a solar flare. So all these energies that are shooting out of the Sun, they are called what? The solar flare, right? We have cooler areas around the Sun, which are the dark areas of the Sun. These are called what? The sun spots, okay? Then we have the atmosphere of the Sun. Just like the Earth has its own atmosphere, the Sun also has its own atmosphere. And this atmosphere is called the corona, and not corona, the alcoholic beverage, and not even the virus. I know you're thinking of that, but it is the atmosphere, and it's called what? The corona. Now, you don't need to know about the other layers of the sun because we didn't cover those in grade 8. Right, let's move on. Again, in grade 8, we learned about objects around the sun. We know that the sun is at the center of the solar system, and it's surrounded by other objects. And these objects are called what? Planets. The very first planet that you find when you move away from the sun, it is the Mercury. It's the closest planet to the sun. Then you have Venus. Then you have Earth and its moon, which is not a planet. Then you have Mars. Then you have Jupiter. Then you have Saturn, Uranium, and lastly, Neptune. These are the 8 planets that are around the sun. They orbit around the sun. Then we also learned about the Earth's position in the solar system. We've already established that the sun is at the center of the solar system and the Earth is rotating around the sun, remember? But the location where we find the Earth, the temperatures are just enough or just right to support life. We know that the Earth is the only planet in the universe that is known to support life. That is because it is located in an area where the temperature is just enough for life to be supported. Now, if we were to take the Earth and put it in this direction, which is towards the sun, life wouldn't be supported. Why is that the case? That is because it would be too hot. And if we were to move it in that direction, life would still not exist. Why? That is because as we're moving away from the sun, it gets colder. So this region here, the temperature is just right because it's neither too hot or neither too cold, right? So it's habitable. Okay, let's move on. Now let's do a baseline assessment, which is nothing but a test, a mini test to test whether you still remember the concepts you learned in previous grades. The first question is, what are the 4 spheres of the Earth? Question 2, what is the atmosphere? Question 3, which minerals are found in the lithosphere? And lastly, why do we need all spheres interacting with each other on Earth? So you have 3 minutes to work on these 4 easy questions, and your time begins now. All right, learners, welcome back. I hope you were able to answer those easy questions. So without any waste of time, let's do them together. So what are the four spheres of the Earth? We did this in our previous lessons. Yes, that is correct. The four spheres of the Earth are the biosphere, the hydrosphere, the lithosphere, and the atmosphere. Today we are learning about the atmosphere. So what is the atmosphere? Anyone? Yes, that's correct. The atmosphere is the air that surrounds us. Okay? Which minerals are found in the lithosphere? Yes, that's correct. We have gold, iron ore, copper, platinum, and etc. Okay? You are more than welcome to have other ones that are not listed here. Why do we need all spheres interacting with each other on Earth? Yes, that's correct. Because together they do what? They support life on Earth. The interaction between the spheres is critical for the supporting of life, okay? To support life. Right, let's move on. Now let's define a couple of terms that we are going to encounter in the lesson so that we don't need to consult the textbook, right? The first term we're going to define is the atmosphere. The atmosphere is a mixture of gases held around the Earth by gravity. The air is the three main gases in the atmosphere, which are oxygen, nitrogen, and carbon dioxide. These are components of the air. Gravity, the force of attraction that the Earth or another astronomical object exerts on an object on or near its surface. We did this when we studied gravitational forces in that term, remember? The troposphere is the lowest layer of the atmosphere, which is closest to the Earth's surface. Next one is the stratosphere. The stratosphere is the second layer of the atmosphere from the Earth's surface. The mesosphere is the third layer of the atmosphere from the Earth's surface. Lastly, the thermosphere is the fourth and thickest layer of the atmosphere. Oh, sorry, there's one more. Then density is the amount of mass in a given volume of a material. Okay, now let's talk about the atmosphere. The composition of the atmosphere is on this table below. So we are going to identify gases that are in the atmosphere, their composition, and their uses. So let's quickly do that. The first gas is nitrogen. Its composition is 78%. And what do we use it for? Well, all life needs nitrogen to make proteins. We need it for protein synthesis, okay? Then we have oxygen. Oxygen is about 21% of the atmosphere. And what are the uses for oxygen? Well, we all need it for breathing. And animal life uses oxygen for cellular respiration. The next one will be other gases, which include water, vapor, and argon. They are less than 1% of the atmosphere. And what do we use them for? Water vapor is water in its gaseous form. Okay, that's water in its gaseous form, which we can use once it comes with the rain. We can use it for irrigation. Right, the last one is carbon dioxide, which is also less than 1%. Okay, and what do we use carbon dioxide for? Plant life requires carbon dioxide for photosynthesis. So plants use carbon dioxide for photosynthesis. Then they manufacture what? Food, and give us oxygen. Okay, let's move on. The atmosphere is made up of a mixture of gases. So the atmosphere is a mixture of gases, and we said it's the air around us. The air is a mixture of gases. This mixture of gases is made up of nitrogen and oxygen, which are the two main gases. And the rest is made up of what? Carbon dioxide, water vapor, and other gases like helium, which are found in trace amounts. Okay. Oxygen makes up 21% of the air in the atmosphere near the surface of the Earth. So oxygen is about 21%, and this is the oxygen that we use to breathe in while we breathe out carbon dioxide. All living organisms need oxygen for cellular respiration, where they produce ATP. We also need oxygen for breathing, okay? Right. The gases are held around the Earth by gravity. And this gravity, if you remember from that term, we did gravitational forces in detail. It is the force that pulls two objects or two bodies together. Okay. So in this instance, gravity pulls the air towards the center of the Earth. Okay. Density of air decreases as one increases the altitude above sea level. Okay. The density decreases as you move away from sea level. Why is that the case? That is because the volume is increasing. At sea level, the volume is small, right? It's just the sea level volume. But when you move away from sea level, the volume becomes bigger. And hence, if you're increasing the volume, the density will decrease, okay? That's why we say as you increase altitude, the density of air will decrease. So air is denser at the sea and less dense on top of mountains. And if you must remember from gravitational forces, we said that the shorter the distance between the two bodies, the greater the gravitational force. But as soon as we pull these objects away from each other, the smaller the magnitude of the gravitational force. Okay. The air gets less dense as you travel further through the atmosphere. So the further you increase the distance, the smaller the density will get. Why? Because the volume is increasing tremendously. Okay? Now let's talk about layers of the atmosphere. We have 4 layers of the atmosphere, even though on these illustrations there's 5. We don't need to know about the last one. We have the troposphere, which is the first layer. We have the stratosphere, which is the second layer. We have the mesosphere, which is the third layer. And we have the last one as the thermosphere. Okay, and in this lesson, we are going to examine all 4 of these layers. So let's begin. The atmosphere has 4 layers, right? That's our starting point. And each layer of the atmosphere has a different temperature gradient, right? So a temperature gradient is a temperature change. Okay, it's like an average temperature that varies between 2 points. Okay, this means that in the atmosphere the temperature changes as you move from 0 kilometers above sea level to 120 kilometers above sea level. So as you move away from sea level, the temperature will change. Okay, on Earth the average temperature is around 15 degrees Celsius, even though different areas may have a certain temperature that is either higher or lower than 15 degrees, but when we take an average of those temperatures, it should give us roughly 15 degrees Celsius. Okay, so now let's talk about the troposphere. We said that the troposphere is the first layer. It is closest to the Earth's surface. Okay, so if this is the surface of the Earth, that means the troposphere starts there. Okay, so it covers the surface of the Earth and a particular distance above the surface of the Earth, right? We call it what? The troposphere. Okay, and it extends and covers even the clouds, right? So we are going to learn about the actual distance as we continue, the distance that it covers above the surface of the Earth. Okay, so all of this shows the areas that are covered by the troposphere. So the troposphere is the lowest layer of the atmosphere, and it is closest to the surface of the Earth. So it extends from the surface of the Earth up to a certain distance above the surface of the Earth. It extends 20 kilometers from the Earth's surface upwards. Okay, so it's like you start from the surface of the Earth and you move up 20 kilometers. That entire area is called what? The troposphere. It is usually heated by the Earth's surface. Because it covers most of the Earth's surface, it tends to have the same temperature as the Earth's surface. But as you move up, the temperature may change. Okay. Its height varies from 9 kilometers high over the equator and about 17 kilometers over the poles, which is north and south poles. Okay. All forms of weather occurs within the troposphere. So all the weather conditions that we experience, whether it's hot, whether it's raining, whether it's snowing, whether there's let's say thunder, it all occurs where? Under the troposphere. Within the troposphere, all weather conditions are occurring within the troposphere. As the density of the gases in this layer decrease with height, the air becomes thinner. So we said that, if you remember, we said that the density decreases as you move further away from the surface of the Earth. Why is that the case? That is because the volume is becoming larger and larger. And if you increase volume, you are going to decrease the density if the mass is being kept constant. Okay. Right. So the density of the gases in this layer decrease as we move up in height. Okay. Right. The troposphere contains about 70% of the mass of the atmosphere. 70% of the atmospheric mass is held within the troposphere. That is a lot. And the mass of the atmosphere is 5 quadrillion tons. That is massively heavy. That's 5 with 15 zeros. That is a lot. And these are 5 quadrillion tons, which is the mass of the atmosphere. And 70% of this is what is held by the troposphere. That is a lot. The mass is made up of air, the main gases, which are nitrogen and oxygen, water vapor, argon, and carbon dioxide. So this mass is made up of these gases. And remember, we said nitrogen takes 28% of this, and oxygen takes 21% of this. So it's a lot. And 50% of the mass sits within the first 6 kilometers from the Earth's surface. Remember, we said that the troposphere extends from the surface of the Earth and up to 20 kilometers. So the first 6 kilometers from the Earth's surface to 6 kilometers is where 50% of this mass of the atmosphere is held. Okay, so the first 6 kilometers is where we find half of the mass of the atmosphere. Okay, now most life lives within the troposphere and all weather happens within this layer. Okay, we've already explained the weather part. So since this layer is closest to the Earth's surface, it covers most of the life. Most life occurs or happens or lives within the troposphere. All wind generated clouds form in the troposphere, but very tall cumulonimbus clouds, which are also called thunder clouds, can stretch into the stratosphere. Right, so all weather conditions occur within the troposphere, but tall cumulonimbus clouds can extend to the next layer, which is called the stratosphere. That's how big they get. Okay. Most aeroplanes fly within the troposphere. So you see how big the troposphere is, from the surface of the Earth up to the sky, where in the clouds where you find planes flying around. That is all part of what? The troposphere. So the troposphere is well adapted to allow the flights of aeroplanes. Okay. The average temperature of the troposphere is 15 degrees, but it can get as cold as minus 89.2 degrees Celsius. That is very cold in the Antarctica, and as hot as 54 degrees Celsius. Now that's very, very hot. Now let's talk about the stratosphere. The stratosphere is the second layer of the atmosphere from the Earth's surface, which means it must begin after the 20 kilometers. Why? Because the first 20 kilometers are covered by the troposphere. So this one must start from above 20 kilometers. Okay, so some aeroplanes fly in the stratosphere to avoid turbulence. Okay, so turbulence is pockets of air which are at different pressure to the air around it. It can cause aeroplanes to lose altitude. So usually when there is turbulence for aeroplanes, they start losing balance and start shaking, and then people panic when they are flying in aeroplanes. That is caused by turbulence. Okay, so some aeroplanes will fly further up into the stratosphere to avoid turbulence. Okay, so in the stratosphere we have a very, very important layer which is called the ozone layer, and it is formed when free oxygen atoms react with oxygen molecules. Remember, an oxygen molecule has two atoms of oxygen which are held together by bonds. Okay, so this is the ozone layer is formed when this molecule, which has two oxygen atoms, reacts with an additional oxygen atom, which ends up forming what? An O3. Ozone has O3. Okay, so it is the layer that protects us from the dangerous ultraviolet rays of the sun. Ozone is naturally split into atoms and molecules by ultraviolet radiation. So the sun's ultraviolet radiation splits the ozone into atoms and molecules. Okay, so the ozone layer protects the Earth from harmful radiation from the sun, and it allows ultraviolet A through but blocks most of ultraviolet B. Okay, so we have two types of ultraviolet lights. Ultraviolet A is the one that we need, but not in excessive amounts. Ultraviolet B is the one that is dangerous and can cause harm. Okay, so we are going to get into these two ultraviolets shortly. So this is the sun, and it releases radiation, and this is ultraviolet A. This is the ozone layer. So the ozone layer permits ultraviolet A to get to the surface of the Earth, but prevents ultraviolet B from penetrating into the surface of the Earth. So ultraviolet A is necessary for humans to make vitamin D, which is useful for the skin. Okay, we need vitamin D, which is what ultraviolet A gives us. But of course, too much of anything is dangerous. If you are overexposed, it can cause skin burns or sunburns and skin cancer. Okay, so you don't need to be exposed to the sun for too long, because you will end up getting skin cancer and sunburns. Ultraviolet B, on the other hand, is a very dangerous form of radiation to all living things. But our clothes, they try to prevent it from striking our skin. So ultraviolet B can cause damage to an organism's DNA. That's how dangerous it is. It can cause defects in your DNA. So you need to stay away from it. So these are effects, adverse effects that you can get from ultraviolet B. Okay, so you have someone here who has a skin problem, which is as a result of being exposed to the sun for too long. That's sunburns. Okay, and then here we have a disruption in the ecosystem where we have fish dying. Okay, these are dead fish or just animals dying because of the dangerous ultraviolet B. So we need to prevent this direct contact with the ultraviolet B, which is basically what the ozone layer is serving for us. It's trying to protect us from ultraviolet B, because that one is very dangerous for all living organisms, not just fish, but all living organisms, and this can disrupt food supply chains if it destroys crops. Okay, we won't be able to get food. Okay, let's continue. So holes in the ozone layer allow all ultraviolet B radiation from the sun to reach the Earth's surface. Now, over the time, you've heard about climate change and global warming, and the ozone layer being the ozone layer having holes which are now worsening by the day, which is as a result of the greenhouse gases that are emitted. And as the ozone layer has holes, it allows now more radiation of the ultraviolet B to get to the surface of the Earth, and this causes a lot of risks for us. So, which is why we need to take action against climate change to avoid adverse effects that may result from the Earth getting warmer. Okay, so holes in the ozone layer allow the UVB, which is the ultraviolet B, which is dangerous, from the sun to reach the Earth's surface, and this puts us at risk. Ultraviolet B causes a reduction in photosynthesis and can cause plants to flower at different times of the year. This can then have consequences on food webs. So ultraviolet B is bad for living organisms. It can cause all sorts of disruptions, like disruption of the photosynthesis, which is a process by which plants create food for us. So we need to take action to prevent that. And this can have adverse consequences on food webs. It can disrupt food production and supply. Right, so this is an illustration of the normal ozone layer and the damaged ozone layer. The first picture here shows the ozone layer in its perfect operating condition. It acts as a shield which shields us from the ultraviolet rays of the sun. Okay, it prevents them from striking us. Okay, we said it allows ultraviolet A but not ultraviolet B, because ultraviolet A is what we need for survival. We need vitamin D for our skin, but we don't need ultraviolet B because it's dangerous. But then when there is emissions of greenhouse gases, either from industrial processes or power stations and whatever, or chlorofluorocarbons, which are mostly found in sprays, they start to damage the ozone layer, and then over time the hole will open up and the dangerous ultraviolet rays will strike the surface of the Earth. Right, so now let's do some questions before we move on to the next layer. Name the layers of the atmosphere. That's the first question. Second, the answers are already there. The layers of the atmosphere are the troposphere, the stratosphere, the mesosphere, and the thermosphere. These are the 4 layers of the Earth. Okay, I'm giving you these answers for free. And the next question, what compounds is the air a mixture of? The air is a mixture of nitrogen, oxygen, carbon dioxide, water vapor, and argon. Okay, so we did this one together, luckily for you. Now, I want to remind you before we move forward, if you have a question for us, you can send it through to our WhatsApp line, which is 064-748-8913. That's 064-748-8913. If you have a question, you can send it through. Let us continue. Now, let's move on to the mesosphere. The mesosphere extends from about 50 kilometers to 80 kilometers above the Earth's surface. But what is the mesosphere? The mesosphere is the third layer from the Earth's surface. We said the first is the troposphere, the second is the stratosphere, then the third one is the mesosphere. The air in the mesosphere is very thin and it's very cold. Okay, so we are moving further up and the temperature will decrease. Okay, they say the higher you go, the colder it gets. Okay, so the temperature in the mesosphere is the air in the mesosphere is very thin and it's very cold. Okay, This layer of the atmosphere still has enough oxygen to burn up space dust and small rocks from space. So there's still a substantial amount of oxygen to burn space dust and small rocks from space. So temperatures drop from -15 to -90 at the top of the mesosphere. The mesosphere helps to protect the surface of the Earth from debris which enters our atmosphere in space. When you look in the night sky and see a bright long streak in the sky, those are bits of rocks. So the debris are rocks coming from space. Meteorites which burn up as they enter the mesosphere. We call them shooting stars. Okay? We call them shooting stars. So some meteorites are too big to burn up completely in the mesosphere and crash into the surface of the Earth. So some meteorites are too big to be combusted by the little oxygen that is within the mesosphere and are permitted to come and strike the surface of the Earth. Okay. The mesosphere is the layer in the atmosphere which scientists don't really know much about. Okay. So there's not much that scientists know about the mesosphere, because aeroplanes and weather conditions and weather balloons, they cannot fly in this layer. So the mesosphere does not allow aeroplanes to fly through. It is not possible for aeroplanes to fly there. And also weather balloons, they cannot fly within the mesosphere. But NASA and other space agencies send special rockets called sounding rockets into the mesosphere to do chemical experiments. So NASA is always trying to find more, they're trying to do research within the mesosphere. So they send shooting rockets, special rockets which are called sounding rockets, into the mesosphere to do chemical experiments just to study and understand what's going on with the mesosphere. Now let's move on to the thermosphere. The thermosphere is the fourth layer of the atmosphere. It is the one that is at the outermost part of the atmosphere. The inner one is the troposphere. Then we have the stratosphere, the mesosphere, then lastly the thermosphere. This one is the outermost layer of the atmosphere. So the thermosphere is the outermost layer of the Earth's atmosphere before space begins. So after the thermosphere, you get into space. This part of the atmosphere begins from 80 kilometers above the Earth's surface and reaches to 370 kilometers. It is the largest layer of the atmosphere. So the thermosphere is the largest layer of the atmosphere. 99% of the Earth's atmosphere, namely the air, is below the thermosphere. So 99% of the air, that is the atmosphere, is held below the thermosphere. So the thermosphere only has 1% of the atmospheric air. The thermosphere is made up of helium, nitrogen, and oxygen. Temperatures can reach over 200 degrees Celsius. So it's very hot within the thermosphere. Why is that the case? That is because it's the outermost layer where the sun's rays strike. Okay? And it's very hard for scientists to take the temperature because the air is so thin. So remember we said there's only about 1% of the air there. So it makes it difficult for scientists to take the temperature of the thermosphere. Okay. The thermosphere blocks harmful X-rays and ultraviolet rays from the sun. When the sun is more active, the temperature in the thermosphere increases. The temperature changes at night and during the day. So the temperature is not stable, it changes during night and days within the thermosphere. Right. Satellites and the International Space Station orbit the Earth in the thermosphere. So we find satellites within the thermosphere. They orbit, and there's also an International Space Station which orbits the Earth in the thermosphere. Okay. The International Space Station is where astronauts live and work all year round. So there is an established International Space Station where astronauts go and work all year long. They use satellites to do their work. And these satellites are located where? Within the thermosphere. So satellites allows us to transmit and receive radio frequencies and telephone signals immediately, and they work because of the spherical shape of the Earth. Okay, so satellites are used to transmit information from one source to the other. Okay, they transmit and receive radio frequencies and telephone signals immediately, and they work because of the spherical shape of the Earth. So they are able to move around the Earth because it's a sphere. Okay. Communication satellites allow radio, television, and telephone transmissions to be sent live everywhere in the world. Like as I'm here today, you are probably watching me in another part of the province. Okay. And the satellites are what's allowing that to happen. We are not in the same location, but there are frequencies that are being transmitted from my end to your end, and you are able to watch me speak in real time. That is because of what? Communication satellites. Okay. And they are useful because they can transmit information anywhere in the world in real time. Okay. Satellites are in orbit, and therefore the signals can be sent instantly into space and then redirected to another satellite or directly to their destination. Okay. At the top of the temperature range in the thermosphere, the temperatures can reach a high of 200 degrees Celsius. But because there is no air, it would, or rather there's less air, it will feel very cold if you went outside your spacecraft. So if you are in the thermosphere, maybe working in the International Space Station, if you choose to get out of your spacecraft, you will experience very cold temperatures because there's less air there. Okay. So now let's try and summarize everything that we've learned about the layers of the atmosphere. So I used this table to do that. We said that the troposphere has a thickness of, okay, it starts from the surface of the Earth to 20 kilometers. So the thickness of the troposphere is 20 kilometers. The thickness of the stratosphere is 50 kilometers. The thickness of the mesosphere is 80 kilometers, and the thickness of the thermosphere is 350 kilometers. The length according to a centimeter scale. So if we were to reduce the scale to represent 1 centimeter, the troposphere would be 1 centimeter. So if, imagine we divide everything here by 20 kilometers, okay? And then we scale that down to 1 centimeter. So the troposphere would be 1 centimeter. The stratosphere would be 2.5 centimeters. The mesosphere would be 4 centimeters, and the thermosphere would be 17.5 centimeters. So the easiest way to work with this, you just take all the numbers that are listed in kilometers and you divide them by that of the troposphere. So if you divide 20 by 20, you get 1. If you divide 50 by 20, you get 2.5. 80 by 20, you get 4. And then 350 by 20, you get 17.5 centimeters. We are reducing the scale to a centimeter scale. The temperature range of the troposphere is between minus 57 degrees up to 15 degrees Celsius. It can get hotter than that, but we are looking at a range, okay? The stratosphere from minus 15 to minus 51 to minus 15 degrees Celsius. The mesosphere from minus 15 degrees Celsius to minus 120. So it's very cold in the mesosphere. And the thermosphere from minus 120 to 200 degrees Celsius. That gets really hot. So what do we find in each of these layers of the atmosphere? In the troposphere, we find the Earth's surface, mountains, and aeroplanes. These are things that you're going to find within the troposphere. The stratosphere, you find the most important layer of them all, which is the ozone layer, which helps to shield us from the ultraviolet radiation of the sun. Then we have the mesosphere, which has meteorites. And then in the thermosphere, we have satellites. Okay. So I hope you understand this summary of the layers of the atmosphere. Okay. Now let's do a quick activity, which is based on the last two slides. Okay. So we have, the instruction says, draw and complete the table showing the layers of the Earth. So now we have the length, which has been reduced to centimeters. Okay. The first one we have 17.5. The second we have 4 centimeters, 2.5 centimeters, and 1 centimeter. What can you find in this layer? Okay. So you have to find what can you find from each of these layers that are represented by these numbers, and then you must name the atmospheric layer. So to do this, I will give you I will give you 3 minutes to work and fill out this table. Okay, and your time begins now. All right, learners, welcome back. I hope you were able to answer and fill out this table, which is based on the previous slides. Right, now I'd like to remind you, if you have a question for us, you can bring it through to our WhatsApp line, which is 064-748-8913. That's 064-748-8913. Okay, so let's quickly fill out the table. We have 17.5 centimeters. Now here's a big clue. This is the largest number that we have. Remember, we looked at thickness of each of those layers, and I told you that to get these numbers, you divide the actual thickness, which is in kilometers, by the thickness of the very first layer. So already from this, you can see this is the thickest layer, and the thickness decreases as you go down. So the smallest one, we can already see what it is, and the biggest one, we can already see what it is. And then the ones in the middle, we can also guess, okay? But you don't need to guess, just give us the correct one. So what can you find in this layer, which is the largest layer? Yes, that's correct. We can find satellites, okay? That's the largest layer. And what layer is this? Yes, this is the thermosphere. Why? Remember, we said it is the thickest layer of the atmosphere. And it was 350 kilometers. And if you divide 350 kilometers by 20, you get 17.5. Okay, so now the next layer. I'm sure you can see we have arranged them in a descending order, so it should be easy to answer the questions, or fill out the table rather. So the one that is 4 centimeters, what can we find in this layer? Yes, that is correct. We find the ozone. What atmospheric layer is this? Sorry, we find the meteorites here. Sorry about that. It's the meteorites. It's not the ozone. Okay? That's what we find in the mesosphere. Then the one that is 2.5, it's where we find the ozone. And what layer is this? That will be your stratosphere. And then the one that is 1 centimeter, that is like the smallest of them all. Okay? Closest to the surface of the earth. Okay? Which one is that? Yes, that's correct. This will be, what we find there is the earth's surface and aeroplanes and mountains, etc. The atmospheric layer is what? It is the troposphere. So let's just recap. We said the largest or the thickest layer will be, we would find satellites, and it is what? The thermosphere. Then we said the next one is, we find meteorites, and it is what? The mesosphere. Then the second layer from the first one is where we find the ozone, and it is what? The stratosphere. And then the very first layer that we get is where we find what? The earth's surface and aeroplanes and mountains, etc. And it is what? The troposphere. So the troposphere is the first layer, and we find the earth's surface, mountains, and aeroplanes within that layer. The second layer is the stratosphere, and that's where we find what? The ozone layer, which is the most important layer that protects us from the sun's ultraviolet radiation. The third layer is the mesosphere, and we find meteorites within the mesosphere. And then the last layer, which is the largest or the thickest, is the thermosphere, and this is where we find satellites. Okay? And the temperature in the thermosphere is very high. It can reach up to 200 degrees Celsius. Now, I don't think there's anyone who can survive that temperature. Okay, let's move on. Now, let's do 2 more questions, and I'll be polite this time around. I will give you the questions, and then you will do them for 2 minutes, and then we will discuss the answers together. So the first question says, explain how density of air changes as you travel from the troposphere to the thermosphere. Oh, the answer is there. Sorry about that. The density will decrease. The air is most dense in the troposphere, and there is less air left once you leave the troposphere. Okay, so let me try and explain this in layman's terms. Okay, so think of density as mass over volume. Okay, so most of the mass of the air is held within the troposphere. Remember, we said we have about 70% of that 5 quadrillion tons being held within the troposphere. So as you move outside the troposphere, you are getting less and less mass, right? So the mass is decreasing as you move up, the mass of the air. And when you get to the thermosphere, you have about 1% of that 5 quadrillion tons. So what does that tell us? The mass is decreasing. What's going to happen to the density? Remember, the formula for density says rho is equal to m over v. Okay, let's rather put the density is equal to mass over volume. So what happens in this equation if you are reducing the mass, right? The density will decrease because the density is directly proportional to the mass. But then what else is happening as we are moving away from the troposphere and moving into the thermosphere? The volume is increasing, okay? So when the volume is increasing and the mass is decreasing, what's going to happen to the density? The density will decrease. I hope that makes a lot of sense about what happens to the density as you are moving from the troposphere all the way towards the thermosphere. Next question. Why does density change? Why does the density change? What do you think? That's correct. Gravity pushes air towards the center of the Earth. As you travel further away from the center of the Earth, gravity decreases and the density of the air decreases with gravity. Okay. Right. Let us wrap up our lesson. It's been a long ride. So we said that the atmosphere is a mixture of gases that are held around the Earth by gravity. The troposphere is the lowest layer of the atmosphere and it is closest to the surface of the Earth. The stratosphere is the second layer of the atmosphere from the Earth and it is thinner than the troposphere. The mesosphere is the third layer of the atmosphere and the air is extremely thin and cold in the mesosphere. The thermosphere is the outermost layer of the atmosphere before you get into space. So after the thermosphere, you get into space. Okay. Then we looked at the thickness, length, according to a 1 centimeter scale, temperature range, and what we find in each of the layers. So in the troposphere, we have 20 kilometers. As the thickness, the length is 1 centimeter, temperature range minus 57 to minus 2 to 15, sorry. And what we find here is the Earth's surface, mountains, and aeroplanes. Stratosphere, 50 kilometers, length 2.5 centimeters, temperature range minus 51 to minus 15. And what we find here is the ozone layer. The mesosphere, 80 kilometers in thickness, 4 centimeters according to a centimeter scale, temperature range minus 15 to minus 120. And we find meteorites within the mesosphere. The thermosphere is the largest one in thickness, 350 kilometers, in centimeters, 17.5, minus 120 to 200 degrees Celsius in temperature range, and we find satellites within this region. Now we're going to take to your WhatsApp questions. If there's anyone with a question, please bring it through to 064-748-8913. So let's quickly go to the WhatsApp and see what questions we have. Okay. It looks like we don't have questions. So let's continue with our lesson, shall we? Okay. Now, when you get to the end of this video, please remember to scroll down and check for complete and continue. That's where you are going to click, and we will know that you indeed watched the lesson from beginning to end, and you will get bonus points for doing that. Right, so in our next lesson, we are going to be looking at mining of mineral resources. We are going to be looking at different forms of mining, and we are going to look at how minerals are mined and sold into the international market. So that's going to be a very interesting lesson. So that brings us to the end of today's lesson about the atmosphere. I hope you learned something, and I'm sorry about the pace. That is because there was too much to cover. Okay, so I hope you learned something about the layers of the atmosphere, and I hope to see you in our next lesson. Please remember to take care of yourself, sanitize your hands, wear your mask, and keep your distance, and keep safe until we meet again for the next lesson where we are going to be mining mineral resources. I am Kwanele Dlamini, your host for this lesson, and this lesson was proudly brought to you by the Gauteng Department of Education. Thank you so much for your time, and keep safe. Bye.